Okay, so let's jump in. Food and clothing are shipped to victims of a natural disaster. Each carton of food will feed 12 people, while each carton of clothing will help 5 people. Each 20 cubic foot box of food weighs 50 pounds, and each 10 cubic foot box of clothing weighs 20 pounds. The commercial carriers transporting food and clothing are bound by the following constraints. The total weight per carrier cannot exceed 19,000 pounds. The total volume must be no more than 8,000 cubic feet. How many cartons of food and clothing should be sent with each plane shipment to maximize the number of people who can be helped? Ooh. Okay, number 1, define the two quantities in the problem, what X and Y are. Okay, you're going to look at what question is being asked. So it asks us how many cartons of food and clothing. Those are going to be our two quantities. These need to be specific. Please do not write X equals food, Y equals clothing. That's not specific. X is going to be the number of cartons of food, and Y is going to be the number of cartons of clothing. So we're putting these cartons of food and clothing in planes to take them to an area that has a natural disaster to help out some people. So number 2, identify the ultimate objective. Again, we are told that maximize the number of people who can be helped. So we want to maximize the number of people helped. So then we need an equation that describes that information or that quantifies that information. So number 3, we're writing the objective function. This is the one that when we did the problems before, it was C equals. And here's what we're looking at. We have number of cartons of food, number of cartons of clothing. We're looking at the number of people that could be helped. What we are told is each carton of food will feed 12 people. So if we have X cartons of food, 12X is the number of people that will be fed. So 2 cartons of food will feed 24 people. Likewise, each carton of clothing will help 5 people. So if we have Y cartons of clothing, 5Y is the number of people that will be clothed. So that is our objective function. Okay. Are we okay so far? Okay. So then if you remember from when we started the basics of linear programming, the next thing we did is we looked at constraints, the things that were limiting us. So there are 2 constraints that will always be the case, and that is X has to be positive, Y has to be positive. We're not going to have a negative number of cartons. And then if we look back through the problem, there's 2 things that are limiting us right up here. One is weight and one is volume. So we're going to have 2 more constraints, one for weight and one for volume. Okay, so we have one for weight and one for volume. Okay, so it says the total weight cannot exceed 19,000 pounds. So whatever the total weight is going to be less than or equal to that 19,000 pounds. And then it says the total volume must be no more than 8,000. So whatever our total volume is has to be less than or equal to 8,000. And again, this has to be in terms of X and Y. Okay, so total weight. We are told the cartons of food are 50 pounds. So that's going to be 50X. Box of clothing weighs 20 pounds, so that's going to be 20Y. Likewise, for volume, the box of food is 20 cubic feet. And then the box of clothing is 10 cubic feet. So those are our 4 constraints. We have 1, The first two will always be the case, and then 3 and 4 here come from the context of the problem. We good so far? Yeah? Okay. So that was all the setup. Now we just need to actually carry out the problem. So for 5, we're going to look at the x and y intercepts. So we're going to copy these inequalities from above. Okay, so if we plug in a 0 for x for this first one, we get 20y is equal to 19,000. So if we divide by 20, we get y to be 950. If we plug in a 0 for y, we get 50x is equal to 19,000. Divide by 50, which gives us 380. Likewise, on the second one, if we put in a 0 for x, we get y to be 800. If we put in a 0 for y, we get x to be 400. Okay. Questions so far? Okay, now we're to our graph. So we're going to graph on that graph in number 7. Now, 2 things to note. When we did the graphing before, we counted by ones. Hopefully we can tell that's not going to be possible here. If we count by ones, we're not going to get up to high enough intercepts. So I'm going to just copy those intercepts again. So we have to graph 0, 950, and 0, 380, 0. And then our second one was 0, 800, and 400, 0. So that's what we're looking to graph. Okay, here's going to be the general process. First, draw in your axes like you did before. There's going to be x. Here's going to be y. We're going to label these with context. So x is the number of cartons of food, and y is the number of cartons of clothing. Okay, and then we have to figure out our scaling. Now, in order to do that, we have to know how many boxes there are. I think there are around 20 boxes. Can you guys count? And I'm going to count also. Okay, here is the way that I normally figure out my scaling. So what I would do is I would say, okay, for y, I need to get up to 950. Now, close to 950, I'm going to round up a little bit, is about 1,000. If I take 1,000 and I divide by those 24 boxes, I'm going to get some number that I don't know off the top of my head. Okay, 41.6. Now, obviously, we're not going to want to count by 41.6. If we count by 40, we're not going to get high enough. So counting by 50, let's say, might be our best option on the y-axis. So that's what I'm going to do is I'm going to count by 50. Now, you don't need to mark every single box. What we know is every 2 boxes is going to be 100. So I have 100, 200, 300, so just keep on going. Okay, similar idea for x. If I look at my two x numbers, the biggest one I have to get up to is 400. If I divide that by 24, I get 16.6. Again, that's not convenient. The closest convenient number is 20. So we're going to go up by 20. So we have 20, 40. Again, because this is so small, I'm just going to do every 2. Okay. We're good so far? Okay, so now we're going to graph. If I graph this first one, I have 0, 950, which is up here, 380, 0, which is down here, and then we have to connect those. Mine's probably not going to be that straight of a line. You should make yours as straight as you possibly can. And then if we test 0, 0 for that first one, we get 0 plus 0 is less than or equal to 19,000, which is true. And this is just the inequality from the previous page. So then I'm going to do the second inequality. I have 0, 800 and 400, 0. And again, if I plug in 0, I get 0 plus 0 is less than or equal to 8,000, which is true. So we shade towards 0, 0 again. Okay, so we have to shade in our feasible region then, which is where both shadings would be true, or both inequalities are true. So be careful with this right side in particular. So then if you remember, we looked for the vertices. We have this vertex right here. I'm going to do them all pretty big in red. We have this one up here. We have this point here. And then we have this point here. Okay, and we're almost done. I know this has been a long problem. So vertices, that first point is 0, 0. And then if we go to the right, that next point is 380, 0. This point looks like it's about 300, 200. And then this point at the very top is 0, 800. So the last thing we have to do is test those out and write an answer, write our final answer. Okay, so what we're going to do, make ourselves a little table. We're going to put those points x, y, and we're going to plug them in to our objective function that we wrote earlier. So we have 0, 0, 380, 0, 300, 200, and 0, 800. So obviously if we plug in 0, 0, we're going to get 0. If we plug in 380, we get 4,560. If we plug in 300, 200, we get 4,600. And lastly, if we plug in 0, 800, we get 4,000. So some things to remember. On the right, these numbers represent the number of people helped. And the other thing to remember, and this one should seem pretty obvious, we want to help the most number of people. So highest number would be this one right here. The last thing we have to do is write those numbers in a sentence. So the maximum number of people who can be helped is 4,600 if we still have to use that 300 and 200. X, if we remember, is the number of cartons of food. So if 300 cartons of food and 200 cartons of clothing are shipped. That is the idea. Questions for me before you do one? Here's the one that you are doing. You're doing the one on the next page that has to do with skis. It's a different context, but it's the same process. What you will notice is I didn't break it up into step by step like I did the previous problem. You still need all the same information, so just go back and refer to the earlier problem so that you can make sure you get all of the steps in.